Hi, and welcome to this edition of Excel for Introductory Statistics. In this activity, we're going to be doing a problem similar to the one we did in the previous video. Another example of correlation and regression. In this example, in column A and B, we have the systolic blood pressure measurements obtained from 10 randomly selected women. One from the right arm, one from the left arm. Now, we have two questions posed here. And the first one is that first yes-no question. Is there a statistical correlation between the systolic blood pressure readings in the right and left arms? Are those two numbers related to each other? Okay, so remember, that's just a simple, not that it's an easy thing to do, but it's simple as in it's very succinctly stated. It's a yes-no question. So yes or no, is there a statistical correlation? The second question is, find the best predicted systolic blood pressure in the left arm, given that the measurement in the right arm is 99. So that's what we have here. So that question mark is where our answer is going to go for this second problem. Okay, and this last statement, use a significance level of alpha equals 0.05. That's relevant to the first question. Okay, so before we answer this one, let me just go over to the second tab, and I have it labeled Choice of Prediction. Okay, so this number line, which I have highlighted part of it green, part of it red, these are the possible values for the correlation coefficient. Now, it could be any number from -1 if there's a perfect negative correlation, up to +1 if there is a perfect positive correlation. Now, numbers close to the 1 and the -1, our answer would be yes, there is a statistical correlation. And numbers closer to, farther away from the plus or -1 or closer to the 0, anything in that red range, we would say no. And those numbers, those points where the no becomes a yes or a yes becomes a no, those are our critical values. Okay, so we have to determine where our correlation coefficient falls in this on this scale. Does it fall in a green range? Does it fall in a red range? Because that will determine what we do next. So this first box is relevant to problem number 1 that we're doing. And then if the answer to problem 1 is yes, then we move on to the second or the lower green box to make our prediction. If the answer to the first question is no, then we move on to the second red box. Okay, so let's answer the first question first, and then we'll come back to this tab. Okay. We're going to be using the Excel function for correlation coefficient, and that's equal. Always start with an equal sign. CORREL, that's for correlation. And in parentheses, we have to tell Excel where the data is. But since we have two sets of data, we'll call generally we call them the X and the Y values. The values on the left, we generally label those the X's. So the right arm measurements will be the X's, the left arm measurements will be the Y's. So we need to tell Excel the location of the X's, and then comma, and then we have to tell Excel the location of the Y's, the Y values. Okay, in this example, the location of the X values is A2. So here are our X values here. A2 up through A11. A2 through A11. So A2 colon A11, and the location of the Y values, those are the left arm measurements. So that would be B2 up through B11. Okay, so that's what we'll put in parentheses, and we'll just type that into this green cell under correlation coefficient. So we want that to equal CORREL. That's our function. And Excel calls these lists, so these locations, arrays. So the array 1 is the first list of numbers. So I'll use my mouse to just select those, A2 to A11, comma, and then I'll select the second array, or I'll select the Y values, B2 to B11. And this will give us the correlation coefficient. Okay, so what's the answer? Yes or no? Our correlation coefficient is 0.604. Well, we can't answer that yet because we need to compare that to something. Where is 0.604? So let me just bounce over to this other tab. Where is 0.604 on this scale of -1 to 1? Does it fall in the green area or does it fall in the red area? Well, we have to figure out what is the critical value. What is the critical value? So let's say there's a -1 there. There's a +1 there, 0 in the middle. Now, our critical value is based on two things. How much data we have, how many pairs of values. In this case, we have 10, so n is equal to 10. N equals 10. So that tells us we're using this row for n equals 10. So our critical values are going to be either 0.632 plus or minus or 0.765. And we're also told that we use alpha, our significance level. Alpha is 0.05. So that just means we use the column for, we have two columns of critical values, one for alpha equals 0.05 and one for alpha equals 0.01. And that level of significance is going to be given to you in the problem. So let me switch colors here to yellow. Blue and yellow makes green. And where these two overlap, you'll see in that green cell, we get a critical value or critical values, plural, of plus or minus 0.632. So that's how we find critical values from this table. And we need two things. We need n and we need significance. So we have a critical value of 0.632, of negative 0.632, so there's our yes range, and let's see if I have a red. Oh, yeah, I have a red. There's our no range, and in this case, our critical value or our correlation coefficient of 0.604 falls in the red range or the no range. So let's put right here R equals 0.604. So the answer is no. No, there is not a statistical correlation between your blood pressure in your right arm and your blood pressure in your left arm. Now, what does that mean in the context of this problem? It probably means you want to, if you're a doctor's office and this is what's happening with your blood pressure machine, it's probably time to get a new machine because you would assume it's the same person, it's the same blood, should have approximately the same blood pressure in the right arm versus the left arm. So this is a case where we can't assume there is a causal relationship, but intuitively there probably is. So since the answer is no, we would probably say, well, it's time to get a new machine, or maybe calibrate the machine that we have. Okay. Now, moving on to question number 2, which is right here. Based on the pattern in the data that we have, what would we predict as the blood pressure in the left arm if the right arm reading is 95? Well, the answer to the first question was there is no pattern. There is no statistical relationship. So let's go back to the second tab, choice of prediction. And this was our answer to question number 1. If the correlation coefficient falls in the red region in the middle, then the answer is no. There is not a correlation. Okay, we have that. Now we move on to this next box for the prediction. Since there is no correlation, there's no relationship between the x values and the y values, we ignore the x value. So we ignore this 95. It doesn't matter what that is. That could have been 195. It could have been 5. We ignored that x value. And for our best predicted y value, we simply use the average of the y values. Notice the last thing I say here is this is a bad estimate. This is a bad estimate. If you're in one of the green boxes, it's a good estimate. So this is what happened in the previous activity, in the previous video with the house prices. It was a good estimate because we determined first there was a statistical correlation. In this case, there's not. So there's no pattern or relationship to work with. When we just use y bar, the average of the y values. Okay, so for the answer to the second question, in place of the question mark, let's use the average function. We're going to take the average of the y values. B2 to B11. And we get 114.4. Okay, so in the previous activity, since there was a relationship, we went ahead and constructed the regression equation. We made a scatter plot, inserted a regression line, added the regression equation to our graph, and so on. We only do that. We only do that if the answer is yes, there is a correlation. In this case, it was a no. All right, that's it for this activity. We'll do one more of these just for practice in the next video, and then we'll move on to probability.